Welcome back, dear students. In this lesson, we will be discussing about function and some features surrounding it that you need to understand when working with Solang Solidity, and as well compare it to vanilla or native Solidity. If we have used some of these functions, especially here, that we're able to deploy and test some of these contracts. So all these are being handled by a function. As you can see it here, the store function gives this, then the retrieve function gives this button for you to interact. So it gives option to interact with this particular function. So let's now break it down based on what we have here. So function declaration can be declared inside or outside the contract. So like we said, this is a contract. You can declare a function within this contract, or some can even be declared outside. That's just in rare cases, but most times your function of your contract usually reside within the contract code itself, but it's good at least you have the idea. And function feasibility, before that, you know, when you are seeing this function, this is a function with the function keyword, then the name of the function, always use a name that is easy to understand what it's about, like this now gets number. So you have idea already what this function will do. So it's good when you name your function like that. Then there are other extra things you are seeing. That's what I want to explain further for you. Like we have this function feasibility. When we discuss about function type, then I was saying there's difference between them. So there's function feasibility. When we have this function, you can see it says public. We have private, we have external, and we have internal. So what does all this visibility mean? Let's take it one by one. So if you go down to these resources, I would like you to go through. So you can see their explanation here that public functions can be called inside and outside a contract, e.g. by an RPC. They are present in the contract ABI and IDL. So this IDL, you need it when you are dealing with like Anchor here now, is used to interact with front end of your Solana smart contract, Solana program. So it can also be private. When it is private function, can only be called inside the contract they are declared. So which means if we make this function private, then as this function is now, for example, let's see this public. I may minimize all this again and then try to redeploy. So this is the contract now. When I deploy this, let's delete everything to avoid confusion. Deploy, yeah, we have this now. You can see I have all this function, which is retrieve, and then another function called store, which is this. And you can see they are both public. Now, what about if I make this private? Let's see what happens. And then try to redeploy the contracts. Each time you make changes, you have to redeploy. You can see. You see that the store is no more visible. Even though it's there, you cannot interact with it through an external dApp or hub or interface like this remix now. This is a kind of front end built to make the testing of your smart contract easier. So when you look at this now, it's not. But it doesn't mean it's not there. It doesn't mean it can't function. It just means if you want to use it, you can call it from another public function that will now make use of whatever this does. Maybe it returns something. It can make use of whatever it returns and then use it in the public function. But you cannot just easily like access that. That's what this is saying. You say can inside the contract they are declared. But then we also have internal. Function can only be called internally within the contract or by any contract inherited the contract. So we have talked about inheritance. Like if you have contract, just like this, like a program or contract, but built like a library. So we can import it and make use of the function. But any function inside here that is labeled as internal, then we can import it and also use it. You understand? So it can be used inside, and it can also be used by any contract that, you know, derive or inherit it. But when you talk about the other one, which is external, function can exclusively be called by other contracts or directly by an RPC. They are also present in the contract API or IDE. So this one is meant to be called outside, not within. So they are meant to be for external call. This is usually used when you feel some things may go wrong and some function may call this particular function, which may trigger something and affect the reliability of the smart contract. So you want to make it external call so that no matter what goes wrong within the smart contract code or the program code, that particular function won't be triggered because it can only be triggered from outside. So those are the type of function feasibility that we have, and you have already seen one of these in action. So if we change this to internal, let's redeploy and test. You see that's not still there, but just this is similar to private. You can see that. I can see it now. This is public, this is private, this is internal. So private, only that contract itself, any public function can call it, can interact with it, but no other person, even if you inherit this contract, you cannot call it and have it work. So, but if you want others to be able to also call it and inherit it and call it, then you want to call it within the smart contract, and also any contract that inherits the contract, you want it to be able to call that function, then you use the internal. But if you want it to be called externally, then you use the external keyword. So let's try and deploy again, then come back and see. So you can see that is now showing, because don't forget what we are saying here is external call, because this is coming from like a front end making call to the smart contract itself. Said it's also so in IDL and all those things. So that's why you can see this function showing up. But if it is not external, not public, then it doesn't mean it doesn't work. It works within, but you can't call it through these external interfaces. It won't work. That's why once you change it up, you see that it doesn't work. So let's turn this back to public. So that's the major thing about the visibility. Then we also have view pure non-payable, similar to what I showed you there, which, let's check this. You see, I have to explain this, that this view is to tell you that this function is not a kind of function that is changing the state of the Solana program or smart contract. So it's just to view. You see, it is just returning. It's not like this that is changing. You can change the value of the contract storage of the smart contract or the program. Here is it now. You see it? It's view. So you can see this now that it doesn't have either view or pure because it is meant to change. It reassign this state variable number and reassign whatever number you put here. That's why when you test this and retrieve it, and then you store this, and then retrieve it, it becomes 23. So you can see the differences between them. So those are part of the things when it comes to the mutability. And there's also payable, which means your smart contracts can receive value like it now on Ethereum EVM, but that's not applicable on Solana in terms of receiving function. So there could be function overload, like function using similar name, as long as maybe the number of arguments is a bit different. So function selector overriding, so you should use this carefully. So there are a lot more you can read in the function and why you are doing. Remember, I told you all these things, they are much. You don't need to know everything. Like, just know the basic, so that as you now work with projects, then you know that okay, this function, this, then you get to know them better. But it's essential you have idea of all these basic things and not just jump into developing a smart contract. It could be more confusing. So if you need any help, don't forget to get into the community, ask for support, and I'll be there to support you. I remain Solomon Foske. Keep the program spirit and alive. See you in the next lesson. Bye.